Good morning, all of you. Welcome to C. Jayendra Rank Zone. We have completed two lectures, lecture 1 and lecture 2 in Ionic equilibrium. Now, in this lecture, so in the first lecture, we have completed about various theories of acids and bases. Now, in this lecture, we are going to discuss new topic. And in second lecture, we have done about dissociation constant of acid and base and how to calculate degree of dissociation from dissociation constant and also ionic product of water. Now, in this lecture, we'll continue with the topic. So please listen carefully. And we have done already some questions based on lectures. Now we are going to discuss new topic. Yes. So relation between Ka and Kb for conjugate acid base pair. It is very, very important. So what is Ka? Ionization constant of acid. And what is Kb? Ionization constant of base. So for conjugate acid base pair, what is the relation between Ka and Kb? Let us see now. For a conjugate acid base pair, the product of Ka and Kb, that is the product of ionization constant of acid and ionization constant of base, is always equal to ionic product of water. Again, I repeat the statement. For a conjugate acid base pair, the product of Ka and Kb, that is called, what is Ka? Ionization constant of acid. What is Kb? Ionization constant of base, and it is always equal to ionic product of water. So that's why we can write Ka into Kb is equal to Kw. At 298 kelvins, always Ka is into Kb, that is room temperature, as I already told you, 25 degrees C. It is equal to ionic product of water. And what is the value of ionic product of water? It is equal to 10 to the power of minus 14. So at 298 kelvins, pKa plus pKb is equal to 14. What is this pK and pKb? We'll discuss later on because this is not relevant here. So before discussing pH, we cannot take pK and pKb. So Ka into Kb is equal to 10 to the power of minus 14. So which is also equal to ionic product of water. So by this, you can write ionic product of water Kw is equal to concentration of H plus into concentration of OH minus, which is also equal to Ka into Kb, that is ionization constant of acid and ionization constant of base, and it is equal to 1 into 10 to the power of minus 14 or 10 to the power of minus 14 at 298 kelvins or 25 degrees C, at 25 degrees C or 298 kelvins. So this is the relation between conjugate acid base pair of relation between Ka and Kb for conjugate acid base pair. Very important point. It is conjugate acid base pair. So what is conjugate acid base pair? In the previous lecture, we have discussed the question. For example, in this case, ammonia plus water gives rise to ammonium ion plus OH minus. And in this, ammonia and ammonium ion and ammonia are called conjugate acid base pairs because ammonia is a base because it is accepting H plus ions from water, and water is an acid because it is donating H plus ions. So that's why. So here water is acid here in this case, and ammonia is base, and this is conjugate acid base and conjugate acid. Conjugate acid and conjugate base. So conjugate acid base pair is nothing but ammonium ions and ammonia. So ammonium ions and ammonia are conjugate acid base pairs, and the relation between the product of Ka and Kb is equal to ionic product of water. It is equal to 10 to the power of minus 14. So please copy down this. Very, very important. Next continuation. Consider the example. As I told you, the example is this. Consider the example of ammonium plus and ammonia. Ammonium plus, when dissolved in water, it forms H3O plus and water. So Ka is equal to H3O plus into ammonia by ammonium ions because Ka is nothing but forward reaction. So forward reaction, H3O plus and ammonia are products since concentration of products by concentration of reactant. Water is taken as the concentration of water is taken as unity. So that's why I have not mentioned here water. So by this we can write for the same way reversible reaction. What is Kb? Kb is equal to concentration of ammonium plus into concentration of OH minus by concentration of ammonia. So net reaction of 1 and 2 becomes pK is equal to minus log Ka. So net reaction of 1 and 2 becomes Net reaction of 1 and 2 becomes, so it is nothing but Ka into Kb. Ka into Kb is equal to, if you multiply with Ka and Kb both, concentration of H3O plus, concentration of NH3 minus, divided by concentration of ammonium plus. So ammonia, OH minus and H3O plus will be forming water again, and only left over is ammonium plus and ammonia. So it becomes, it is equal to ionic product of water, because if you take into consideration, so let us consider now here Ka value. What is the value of Ka? Ka is equal to concentration of H3O plus into concentration of ammonia by concentration of ammonium plus into Kb value is concentration of ammonium plus into concentration of OH minus by concentration of OH minus by concentration of ammonia. So in this case, concentration of ammonia gets cancelled, ammonium gets cancelled. So what is left over? Only H2O plus and OH minus, which is equal to Kw. So by this we can say Ka into Kb is always equal to Kw. For conjugate acid base pair, Ka into Kb is equal to Kw. For conjugate acid base pair, Ka into Kb is equal to Kw. So this is clear now. So ammonia gets cancelled, concentration of ammonia gets cancelled, concentration of ammonium ion also gets cancelled. Only left over is concentration of H3O plus, which is also called as H plus. H plus and H3O plus are almost similar, and into OH minus. That is nothing but ionic product of water, because Kw is also equal to concentration of H3O plus plus concentration of OH minus into concentration of OH minus. So this is the product of Kw, and it is equal to 1 in 10 to the power of minus 14, as we already know. So by this what we can say, always Ka into Kb is equal to Kw for conjugate acid base pair. So this relation is very, very important. Please note it down. In the numericals also they will ask in the examination. Next continuation. Sorry. What are pKa values and pKb values? So pKa is always equal to, that is negative logarithm of Ka, and pKb is equal to negative logarithm of Kb, which is equal to log of 1 by Ka, log of 1 by Kb, because log A minus log A is equal to log 1 by A, and pKw is equal to minus log Kw is equal to 1 by log 1 by Kw, and always pKa plus pKw, sorry, pKb is always equal to 14, because pKa value and pKw value is equal to pKa plus pKb is equal to pKw. So pKw is equal to negative logarithm of 1 in 10 to the power of minus 14. So which is equal to minus of minus becomes plus 14 log base 10 to the log 10 to the base 10. So which is equal to, because it is plus, because minus and minus becomes plus. So which is equal to log 10 to the base 10 is equal to 1. So it is equal to only 14. So by this you can say pKa plus pKb is equal to 14 are also equal to pKw, where pKw is equal to negative logarithm of Kw. So what is negative logarithm of Kw? It is equal to 14. So what is this negative logarithm? This is, we are going to discuss next topic, that is pH values. So these three formulas are very important. So pKa, pKb, and pKw. And pKa plus pKb is always equal to pKw, which is equal to 14. So this is very, very important relation. Please note it down. I hope you have noted it in your classwork. So let us proceed to next slide. Relative strength of acids and bases. So strength of acid 1 is equal to root of Ka1 by strength of acid 2 is also equal to root of Ka2. Strength of base 1 is equal to root of Kb1 by strength of base 2 is equal to root of Kb2, because it is based on alpha. Since alpha is equal to root of Ka by C, so how we got this relation? Since alpha is equal to root of Ka by C, so strength of acid 1 is equal to root of Ka1 by root of Ka2. So by this you can do strength of acids and bases. Next continuation. Relation between Ka, Kb for conjugate acid base. relation between Ka and Kb for conjugate acid base pair continuation. So let us consider 2 moles of water gives us to the H3O plus OH minus. So Kw is equal to concentration of H3O plus into concentration of OH minus divided by concentration of water. Since water is taken as unity, if can be seen that net reaction equilibrium constant is equal to product of Ka into Kb. So for a conjugate pair, Ka into Kb is always equal to Kw. This already we have proved it. This already we have proved in the first case itself. So Ka into Kb is always equal to Kw. That is called ionic product of water. What is ionic product of water value? Is equal to 1 into 10 to the power of minus 14 at 298 kelvins. As the temperature increases, ionic product of water also value also increases. Next, if Ka value is in the order of 10 to the power of minus 3 or more, then alpha value should not be neglected. So if Ka value is in the order of 10 to the power of minus 3 or more, then alpha value cannot be neglected, should not be neglected. So then Ka is equal to C alpha square by 1 minus alpha. Then Ka is not equal to C alpha square because alpha is value is not small. That is 1 minus alpha is not equal to 1. So in which cases we'll get this? For strong acids, we'll get this. For strong acids, we'll get this. For weak acids, we'll get 1 minus alpha is neglected. So for weak acids, sorry, Ka is always equal to C alpha square by C alpha square only because 1 minus alpha is neglected. But for strong acids, Ka is equal to C alpha square by 1 minus alpha because for strong acid, Ka value is of the order 10 to the power of minus 3 or more. So please note down this, very, very important. Now, problems based on dissociation constant of acid, base, and also degree of dissociation, that is alpha. Let us see now. Example 1. Calculate the amount of acetic acid in 1 liter of its solution. Acetic acid in 1 liter of its solution. They have given volume as 1 liter. Given alpha is equal to 1% and Ka is equal to 1.8 in 10 to the power of minus 5. So they are asking us to find amount of acetic acid in 1 liter of its solution. So amount of acetic acid means amount of acetate ions in 1 liter of its solution. That is acetic acid. We can write here acetic acid. Since alpha is equal to root of Ka into C, implies root of K into 1 by V because, sorry, root of Ka by C. Since alpha is equal to root of Ka by root C. So we can write root of K into V. So since they have given volume, so it is nothing but root of 1.8 in 10 to the power of minus 5. And they're asking what? They're asking calculate the amount of acetic acid. So to calculate the amount of acetic acid, what is the formula we have to take into consideration? Amount of acetic acid in 1 liter of its solution. So alpha, we know alpha is given as 1% by volume. So straight away we can find C value instead of taking volume also because volume is given 1 liter only. So straight away we can take, again I'll explain this clearly, just please note down. So they're asking us to find concentration and we know alpha value is 1%. 1% means it is 1 by 100. Since alpha is equal to 1 by 100, so it is equal to 0.01. So by this we can write C is equal to root C is equal to, so simply we will square it. So alpha square is equal to Ka by C, implies C is equal to Ka into alpha square, that is equal to 1.8 in 10 to the power of minus 5 divided into alpha square is 1 by 100 whole square. So we can take 1 by 10 square whole square. So 10 to the power of minus 4. So 10 to the power of 4 it will become, so it is equal to 1.8 in 10 to the power of minus 5 into 10 to the power of 4 because 1 square is only 1. Because 1 square is only 1, so 10 to the power of 4 which is equal to 1.8 in 10 to the power of minus 1. So let us check the answer. That is a concentration, but they are asking here. So it is equal to 1.8 10 to the power of minus 1. So this can be taken as 10.8. So 10 square, it is 10 to the power of 4. Ka into alpha square, because alpha is equal to root of Ka by C. So alpha square is equal to Ka by C. So C is equal to Ka into alpha square. In this way, you have to find the answer. Please copy down this. Since they are asking amount of acetic acid, so amount of acetic acid means we have to calculate concentration. Next question. Calculate the degree of ionization of 0.01 molarity solution of HCN. Degree of ionization. Ka value of HCN is 4.8 in 10 to the power of minus 10. Calculate hydronium ion concentration also. So two things they are asking us. So first, from concentration we can find out. So degree of ionization means alpha. They are asking alpha is equal to how much? Since HCN, hydrogen cyanide, is a weak acid, so Ka of weak acid is 4.8 in 10 to the power of minus 10. So alpha is equal to, root of Ka by C. This 0.01 can be taken as 10 to the power of minus 2. So that is equal to root of 4.8 into 10 to the power of minus 10 divided by 10 to the power of minus 2. So 10 to the power of minus 2 goes to numerator. It becomes root of 4.8 in 10 to the power of minus 8, because 10 to the power of minus 2 goes to numerator, 10 to the power of plus 2. So it is equal to 10 to the power of minus 8. So if you find the root of 4.8 10 to the power of minus 8, we'll get the value of alpha percentage. So straight away we can take alpha. Then to find concentration of hydronium ions means H3O plus ions is equal to C alpha, with the formula C into alpha. So you know already C value and alpha value you'll get from it. So by this you can write C value is 10 to the power of minus 2 into root of 4.8 into 10 to the power of minus 8. So by calculating this value, so root of 4.10 to the power of minus 4 whole to the power of 2. So this becomes 10 to the power of 4, 10 to the power of minus 2, 10 to the power of 6 will be there, and 4.8. So let us check the answer now. You can calculate there itself. And as I told you, 10 to the power of minus 4, 10 to the power of minus 2 becomes 10 to the power of minus 6, and root 4.8 is 2.2. So answer is 2.2 10 to the power of minus 6 moles per liter. So what is the value of this? Answer is what? It is equal to 2.2 into 10 to the power of minus 6 moles per liter is the unit. So please note down. Straight away, alpha is equal to root of Ka by C. So root of Ka by C, C is equal to 0.01. That can be written as 10 to the power of minus 2. So by this you can say root of 4.8 10 to the power of minus 8, because 10 to the power of minus 2 goes to numerator, it becomes 10 to the power of plus 2. 10 to the power of minus 10, 10 to the power of plus 2, it becomes 10 to the power of minus 8. And root of 4.8 10 to the power of minus 8. And HCO plus concentration is equal to C alpha. So C value is 10 to the power of minus 2 into alpha value is root of 4.8 10 to the power of minus 2. So this becomes 2.2 10 to the power of minus 4. So 2.2 10 to the power of minus 4 and 10 to the power of minus 2 becomes 2.2 10 to the power of minus 6 moles per liter. So this is clear. Very, very important model. So this type of questions you'll get in the entrance examination. So please note it down. They are asking us to calculate the degree of ionization of 0.01 molarity solution of HCN, and Ka value of HCN is given 4.8 10 to the power of minus 10. Also calculate hydronium ion concentration. Hydronium ion concentration is equal to C alpha. This formula is new, so it's very, very important. So please note it down. Next question. 0.16 grams of hydrazine, that is N2H4, are dissolved in water, and the total volume made up to 500 ml. So they have given weight of N2H4 and volume also. Calculate the percentage of N2H4 that has reacted with water in this solution, and Kb for N2H4. This is a base, so it is Kb for N2H4 is given 4.0 10 to the power of minus 6 molarity. So to find percentage of NH4 that has been reacted with water is nothing but what? It is nothing but alpha. They are asking in this question, alpha is equal to how much? And we know since this is a weak acid, so a weak base, so alpha is equal to root of Kb by C. And how to find C? Since C is equal to concentration is equal to number of moles by volume of solution liters into 1000. Because if the volume is given in ml, we can take N into V by 1000. And how to find and weight by molecular weight? Weight by molecular weight into 1000 by volume. So this, if you substitute, what is the weight of N2H4 is given 0.16. And what is the molecular weight of N2H4? Nitrogen 2 14 is 28 plus 4 32. So it is 0.16 by 32 into 1000 by 500. And 500 ones are 500 twos are. So 32 16 times. So it is equal to how much? 0.16 by 16. It is equal to 0.016. 0.016. So after finding this, you know the value of C. So substitute the value of C. Alpha is equal to root of Kb by C. What is Kb value? 4 into 10 to the power of minus 6. So if you substitute this value and do calculation by C value you got it from here. So you do it here, 100% you'll get the answer. And the answer will become 2%. Means nothing but 0.02 you should get. If you get 0.02, then that is the right answer. So 0.16 by 16 is equal to 16 one time. So 0.01, it is not 0.016, it is 0.01 only. That is 10 to the power of minus 2. Because it is coming 1 times 10 times. So it is 0.01, 1 by 100. So nothing but 0.01. So after getting 0.01, the value of C is equal to 4.0 in 10 to the power of minus 6 by 0.01, that is 10 to the power of 2 minus 2, 10 to the power of minus 2 goes to numerator. So it becomes 10 to the power of plus 2. So 10 to the power of minus 4. Minus 4, what is 4 in 10 to the power of minus 2. So, so it is equal to, so if you calculate this 100%, you will get 2%. So in this question, what they are given? They are given weight and volume. From weight and volume, you can find molarity, that is concentration. Concentration is equal to number of moles of solute by volume of solution liters. If it is in ml, we have to multiply with 1000. So weight by molecular weight, because number of moles we can be calculated by using the formula weight by molecular weight. Weight is given 0.16 grams and molecular weight is given 32. So 0.16 by 32 into 1000 by 500. So 16, 0.16 by 16, it is equal to 0.01 or it is equal to 10 to the power of minus 2. So substitute this value in this equation. So you'll get 4 root of 4 into 10 to the power of minus 6 by 10 to the power of minus 2, which is equal to 4 into, that is equal to, here I'm writing, you can understand, if you calculate this, you'll get 0.02, which is equal to 2%, because alpha is equal to 100 into 0.02. Alpha is equal to alpha into 100%, because they're asking percentage. Percentage means alpha. So it is percentage. Whatever the value you'll get, you'll multiply with 100. You'll get the answer. So this is clear for you. Very important model. This type of questions you will expect for entrance exams. So please note it down. More and more we'll do it clearly. Once again, next question, if it is there. So this is an important model. Please note it down. Next question. Calculate the degree of ionization of pyridine. Formula is C5H5N. They are asking us to calculate degree of ionization, that is alpha. Pyridine in its 0.1 molarity solution. Kb for pyridine is given 1.5 10 to the power of minus 9. They have given C value. Also, they have given Kb value. What would be the degree of ionization of pyridine? The solution is also 0.1 molarity in NaOH. In NaOH, what is its molarity? So degree of ionization. So straight away you can find alpha is equal to root of Kb by C. So Kb is given is equal to 1.5 into 10 to the power of minus 9 divided by C value is given how much? It is 0.1 molarity solution. So which is equal to, you can calculate the values, easily you'll get the answer. And let us see the answer in the first case, and second case also I'll explain you now. Second case also the same, because whatever the solvent will be, the molarity is same. So it is equal to 1.5 10 to the power of minus 8, root of 1.5 10 to the power of minus 8. There is the value of alpha in an NaOH solution. So it should be root of 1.5 10 to the power of minus 8, because 10 to the power of minus 9 goes to numerator. So it becomes 10 to the power of minus 8. And both alphas they are giving, so alpha square. So alpha square if you are taking, so 1.5 10 to the power of minus 8. So this formula is very, very important. Please note it down. Next question. Next, we have acidity and pH scale. How to find whether a substance is acidic or basic or neutral? That can be done by pH scale. And pH scale was introduced by so and so. Very, very important pH topic. So from pH topic, everything is important now. So very, very important. From this chapter, definitely you are going to get 2, 3 questions in the entrance exam. So please listen carefully. All the important models we'll discuss and we'll do it accordingly. Now coming to pH, let us see now. Acidic strength means the tendency of an acid to give H3O plus or H plus ions in water. Both are same, H3O plus or H plus hydronium ions or H plus ions in water. So based on that, we can say a substance is strongly acidic or strongly weakly acidic. So greater the tendency to give H plus ions, greater the tendency to give H plus ions, more will be the acidic strength of the substance. Greater the tendency to give H plus ions, more will be the acidic strength of the substance. So basic strength means the tendency of a base to give OH minus ions in water. So how can we decide whether a substance is basic or not? It is based upon the tendency of a base to give OH minus ions in water. Greater the tendency to give OH minus ions, stronger will be the basic character. So basic strength of the substance. So by this, what you can understand, if an acid gives more amount of H plus ions, it is strongly acidic. If a base gives more amount of OH minus, it is strongly basic. So based on this only, we have decided a scale. So and so designed a scale called pH scale. The concentration of H plus ions is written as in simplified form introduced by so and so as pH scale and defined as negative logarithm of activity of H plus ions. So what is pH? It is nothing but negative logarithm of activity of H plus ions. So pH is equal to minus log of H plus ions, where AH plus is the activity of H plus ions, or simply activity of H plus ions is the concentration of free H plus ions or H3O plus ions in a dilute solution. What is the activity of H plus ions? It is the concentration of H plus ions or H3O plus ions in a dilute solution. And the pH scale, as we already know, because it is there in 10th class also, was marked from 0 to 14 with central point 7 at 25 degrees C, taking water as solvent. Very, very important point. So how the pH scale is designed? It is based on, it is a scale which consisting of marks from 0 to 14, and the central point is 7 at 25 degrees C, taking water as solvent. So pH of water is always equal to 7. Since water is neutral, we can say pH of water is equal to 7. And pH scale was designed by, introduced by so and so. So and son, very, very important. Please note it down. And based on pH values, definitely they'll give questions based on pH. If the temperature and the solvent are changed, then pH change of the scale also will change. For example, 0 to 14 at 25 degrees C, neutral point is pH is equal to 7. Very, very important. This point also they can ask in the examination. So at 25 degrees C or 298 kelvins, this is the values of pH values, standard values. And whereas if it is at 80 degrees C, as the temperature is slightly increased, then Kw value decreases. That is, Kw value increases, we can say. So pH becomes, neutral point becomes 6.5. So pH can also be negative or greater than 14. Depending on the temperature, pH can also be negative or greater than 14. Very, very important. But generally, we'll use this scale only. And suppose if they ask any question in the examination, if the temperatures increase, automatically Kw value increases. Kw value increases means minus power decreases, as minus power 10 to the power of minus 14 is actual Kw value, and it decreases to minus 10, minus 11, minus 12, minus 13, depends upon the temperature. So for example, the pH scale ranges will be 0 to 13 at 80 degrees C, and Kw becomes, because at that in that position Kw becomes 10 to the power of minus 13, and neutral point becomes exactly half of that is 6.5. And here it is 14, because Kw value is 10 to the power of minus 14. Half of neutral point is exactly half, that is 14 by 2, it is equal to 7. So we can write neutral point based on Kw values. Half the Kw value is positive power, it is nothing but neutral point. So pH can also be negative or 4 greater than 14. It's not like that pH is always 0 to 14. It depends upon the temperature. But at standard temperature, we can say pH is always equal to, pH is always ranges from 0 to 14. Only at room temperature, that is 298 kelvins. So pH values will be in the range of 0 to 14 only at room temperature. If you take the temperature either less or more, automatically the pH values also will change. So please note that point. in your classwork. Next continuation, range of pH scale. So from 0 to less than 7, almost it is 6.9 also it is called as acidic. So 0 to less than 7 it is acidic, and exactly 7 it is neutral, and greater than 7 it is basic. So battery, acid, lemon juice, wine, normal rain, distilled water. So this is the pH value of distilled water. This is the pH values of baking soda. Baking soda is sodium bicarbonate, which is a base, sodium bicarbonate, and soft ammonia, soft soap, and the pH value of ammonia is more, and pH value of lye. Lye is also just like it's like Fevicol, which is used for sticking purposes. This is called lye, and this lye, the pH value is equal to 14. So 0 to less than or equal to less than 7, it is acidic in nature. The pH value of a solution is in the range of 0 to less than 7, it is acidic in nature. If the pH value of a solution is in the range of greater than 7 and equal to 14, the range of 7 to 14 equal to 14, we can say the solution is basic. And the pH of a solution is equal to 7. If pH is equal to 7, it is neutral. It is what? Neutral. This value is already you know. And more lesser the value of acidic pH value for an acid is less, more strongly acidic it is. And greater the value of pH value of a base is, more stronger is the base. For example, if pH value of an acid is equal to pH value of acid A is equal to 1, and pH value of an acid B is equal to 2. So which is more acidic? A is more acidic than B. A is more acidic than A is more acidic than B. Similarly, if pH of a substance is equal to pH of a substance P, let us say some substance P is equal to 9 and pH of Q is equal to 14. For example, I'm giving, then pH of Q is more basic than P. Q is more basic than P. So in this way, we'll calculate pH values. And how to calculate pH value? Simple formula, pH is equal to minus log of OH plus H plus concentration. Minus log of H plus concentration is equal to pH. Directly we can do like this. Very, very important. So we'll do models based on pH values. I'll show all the models. So please listen carefully. Definitely you'll get a question from pH also. Next continuation. Similar to pH, pOH of a solution. For acids, we'll take pH, and for base, we'll take pOH of a solution is the negative logarithm of concentration of hydroxyl ions. What is this called? Concentration of hydroxyl ions. Hydroxyl ions means OH minus ions. Concentration of OH minus ions expressed in molarity. pOH is the logarithm of reciprocal of concentration of hydroxyl ion concentration expressed in molarity. That is negative logarithm of OH minus. So we can calculate pH is equal to minus log of H plus ions, and pOH is equal to minus log of OH minus ions. And always pH plus pOH is equal to pKW, which is equal to 14. At 298 kelvins, for pure water or neutral solution, pH is equal to pOH is equal to 7. Very, very important. All these points are very important. Please note down, because without these points, you cannot solve numericals easily. And for acidic solution, pH should be less than 7, and basic solution, pOH should be greater than 7. And similarly, for basic solutions, pH is greater than 7 and pOH is less than 7. Very, very important. pOH should be less than 7 and pH is greater than 7. You can see here the difference. How it is possible, I'll show you in the next slide. So when they're doing the models. So pH plus pOH is always equal to 14. Please note down, this is very, very important. Now let us see some questions based on pH. Calculate the pH of 0.03 molarity HCl solution. How to calculate pH value of 0.03 molarity HCl solution, assuming that HCl are completely ionized. Completely means 100%. Alpha is equal to 1. So pH is equal to, we know pH is equal to negative logarithm of concentration of H plus ions. And since pH is equal to negative logarithm of concentration of H plus ions, we can say minus log of 0.003 can be taken as 3 into 10 to the power of minus 3. 3 into 10 to the power of minus 3. So minus log of 3 into 10 to the power of minus 3. Since 3 into 10 to the power of minus 3. So minus 3 minus of minus log, it becomes plus. So it becomes 3 log 3. 3 log 3. 3 log 3. Log 3 value is, since log 2 value is 0.3010, log 3 value is 0.4771. So 3 into 0.477, because log 3 value is 0.477. So by substituting this value, you will get it as answer. What is the answer you'll get? Let us see. Multiplication part you can do. So it is equal to 2.52. Is equal to how much? 2.52. In this way, we can calculate pH value. This is only basic question, basic model. So please note it down. In this way, you have to calculate. So pH is equal to, what is the formula? Since it is acid, directly we can take minus log of OH plus ion. So H plus ion concentration is given already 0.003 molarity. It can be written as, always you convert them into tens powers. So it will be easy for you to calculate. So it can be written as 3 into 10 to the power of minus 3. If you take 3 into 10 to the power of minus 3, definitely it is equal to 0.003. So 3 into 10 to the power of minus 3, 10 to the power of minus 3 minus log. So minus 3 minus means here it becomes 3 log 3. 3 into log 3. Log 3 value is 0.477, as we already know. So if you multiply 3 into 0.477, it is almost equal to 2.52. Next question. Calculate 0.02 molarity of NaOH solution. See, this is a base. NaOH, by seeing itself, we can say base. And they are given concentration of OH minus. First, concentration of OH minus is equal to, we have to take into consideration, it is equal to 2 into 10 to the power of minus 3. How much we have to take? 2 into 10 to the power of minus 3, because since NaOH gives OH minus ions. So now we can, first we have to calculate POH. POH is equal to minus log of 2 into 10 to the power of minus 3. POH is equal to minus log of 2 into 10 to the power of minus 3. Minus 3 and minus, so it becomes 3 log 2. It becomes how much? Plus 3 log 2. Log 2 value is 0.3010. So 3 into 0.3010. So this becomes the answer POH. So 3 into 0.3010. So straight away, simply we'll take 0.3010 into 3. So if you multiply here, I'm doing in the margin 300, 3 ones are 300, and 3 3s are 9, 0 and 300, so 0.9. So POH is equal to 0.9. 030, but they are asking us to calculate pH. So pH becomes 14 minus 0.930. How we got this? Because since pH plus POH is equal to 14, since pH plus POH is equal to 14, so POH is equal to 14 minus pH. 14 minus pH, because POH is equal to, so pH is equal to 14 minus POH. So by taking this formula into consideration, we got 14 minus 0.9. So let us check the answer now. So it could be 11.30. So 0.9030, 3 into 0.93 log 2. So we have to multiply this. So it should be less than, somewhere calculation part we are done. But anyway, this is the calculation we have to do. So here itself I am stopping now. So this you multiply, because log 2 value is 0.3010. So 3 into 0.3010. After getting POH, we can take pH is equal to 14 minus POH. So 14 minus POH value, after multiplying this, you will get the answer. So this should be definitely 11.301. So in this way, you can calculate pH of sodium hydroxide solution, because sodium hydroxide gives, when dissolved in water, it gives Na plus and only one OH minus. So this is model number 2. Model number 1 we have done. Model number 2, like that we have 7 to 8 models for this types of pH. So all these 7 to 8 models we have to do completely so that you will become perfect in pH problems. Next, calculate H plus ion concentration in acidic solution of pH is equal to 4.301. Since they have given pH is equal to 4.301 and H plus concentration is equal to, so pH is equal to minus log of H plus concentration. What is the value of pH? pH is equal to minus log of H plus concentration. So by this implies pH H plus concentration is equal to H plus concentration is equal to 10 to the power of minus pH. What is this called? Again, I'll write here. 10 to the power of minus pH. Straight away, this is the formula. So 10 to the power of minus 4.301, you'll get the answer as 5.0 10 to the power of minus 5. So concentration of H plus is equal to 10 to the power of minus pH. For example, generally this requires calculation, but generally they'll give pH is equal to 3. So if pH is equal to 3, for example, if pH is equal to 3, then H plus concentration is equal to, H plus concentration is equal to 10 to the power of minus 3. Straight away you can take this, because minus log of 10 to the power of minus 3 becomes 3. So that's why if pH is equal to 3, then H plus concentration is equal to 10 to the power of minus. In the same way, H plus concentration in this numerical 10 to the power of minus pH, that is 10 to the power of minus 4.301. After calculating, you'll get 5 in 10 to the power of minus 5 molarity. So this is model number 3. So we have done 3 models in pH problems, but more and more also we'll do. Next question. Calculate OH minus ion concentration in the basic solution of pH is equal to 2.699. So let us take here also, this is calculation part, and this much more calculation part they not given the examination. Since pH is equal to 2.699 implies POH is equal to 14 minus 2.699, which is coming around 2.7. Let us take into consideration. So 2.7 means it should be 12.3, approximately 12.3. Then concentration of OH minus concentration is equal to 10 to the power of minus 12.3. 10 to the power of minus 12.3, because concentration of OH is equal to 10 to the power of minus POH. Since POH value is given as 12.3. So 10 to the power of minus 12.3 is the answer. And for this, after calculation, generally they'll give easy question. So 5.2 into 5 into 10 to the power of minus 12. 5 into 10 to the power of minus 12. So for example, I'll give you, if POH is equal to 9, then implies concentration of OH minus is equal to 10 to the power of minus 9 moles per liter. That is molarity. So these type of questions are important. Please note it down. Next model. Some more models based on this. So total 4 models we have done. Now we'll do model number 5. Model number 5, basic problems. From pH. Please listen carefully. From now onwards, it's very, very important. I'm going to do more tougher questions. Calculate the pH of 0.01 molarity sulfuric acid solution. So they're asking us to calculate the pH of 0.01 molarity sulfuric acid solution. These type of questions are important. I'll do the solution with a blue pen. So let us see. I'm not giving options. So straight away I'm doing solution. So since sulfuric acid is dibasic, so it is nothing but as it is yielding H2SO4 when dissolved in water, it yields 2 H plus ions. That's why it is called dibasic and SO4 2 minus. So since it is dibasic, so we can write concentration of pH 0.01 molarity is called 0.01 molarity can be taken as 10 to the power of minus 2. And this becomes pH concentration of H plus ion solution is equal to 2 into 10 to the power of minus 2. Why we have taken 2 in 10 to the power of minus 2? Because it is 10 to the power of minus 2 for 1 H plus, but since it is giving 2 H plus, so 2 into H plus, 2 into H plus is equal to 2 in 10 to the power of minus 2. We have to multiply with 2. So then H plus concentration becomes, H plus concentration is equal to 2 in 10 to the power of minus 2. Since H plus concentration is equal to 2 in 10 to the power of minus 2, so pH is equal to minus log of 2 into 10 to the power of minus 2, which is equal to, 2 into 10 to the power of minus 2. So minus 2 minus, so it becomes 2 log 2. So 2 into log 2 value is 0.3010. So 2 into 0.3010. So if you multiply this, you'll get the answer. So pH is equal to 2 into 0.3010. This multiplication part I'm not doing. So this is the answer. In this way you have to do, since it is dibasic. So whatever the concentration is given, we have to multiply with 2. Why we are multiplying with 2? Because it is nothing but since sulfuric acid is gives 2 H plus ions. Similarly, we can do the same question in another model, that is model number 6. Let us do model number 6. Please note down this model. You please copy down in your exam, in your classwork. Next, we are going to do model number 6. Next, we do model number 6. Calculate the pH of 0.01 molarity barium hydroxide solution. Barium hydroxide solution. They will not give formulas. Simply, I'm giving formulas to you. So pH of, they are asking us to calculate the pH of barium hydroxide solution. So I'll do solution for this clearly step by step. Please note it down. Since barium hydroxide is a base, so for this we have to write concentration of OH minus is equal to 2 into 0.01. That is equal to 2 into 10 to the power of minus 2. Because 0.01 is 10 to the power of minus 2. So concentration of OH minus becomes 2 into 10 to the power of minus 2. So by this, first we have to find pH, POH is equal to, because since barium hydroxide also dissociates 2 yield, so barium hydroxide contains 2 OH minus ions. So concentration of OH minus is equal to 2 into 0.01, and it is equal to 2 into 10 to the power of minus 2. By this, we can write POH is equal to negative logarithm of 2 into 10 to the power of minus 2. And by this, we can say POH is equal to 2 log 2. That is equal to 2 into 0.3010, because log 2 value is 0.3010. Then pH is equal to 14 minus 2 into 0.3010. In this way, you have to calculate the answer. 0.01 molarity barium hydroxide solution. Barium hydroxide, because since barium hydroxide dissociates to yield 2 OH minus ions. It gives 2 Ba plus 2 plus 2 OH minus ions. And since this is a base, first we need to calculate. Since it is a base, first we need to calculate concentration of OH minus. In this case, concentration of OH minus becomes 2 into 0.01. That is equal to 2 into 10 to the power of minus 2. So minus log of 2 into 10 to the power of minus 2 is POH. And POH is equal to 2 log 2. That is 2 into 0.3010. And since pH plus POH is equal to 14. So pH is equal to 14 minus pOH. Since pH is equal to 14 minus pOH, so you will get the answer like this. So in this way, we can calculate pH values. These are all basic models up to only NEET level, and more questions we'll do, and advanced level and mains level also will do. So for that, they'll give little bit calculation part. So here also I'm not calculating. You can do multiplication 0.3010 into 2 and 14 minus 0.3010. You'll definitely get the answer. Next question. Next, before going to pH in the next lecture, next session anyway, we are going to do more about pH. Now we'll do questions based on dissociation constant of acid and base. Dissociation constant of acid and base. So let us see now. A monobasic acid, very, very important model. Model number 6, model number 7. Very important model for mains level. A monobasic acid solution. I'm writing the question. A monobasic acid solution. A monobasic acid solution has pH value 5. Has pH value 5. Its molarity is 0.005. 0.005 molarity. The degree of ionization of the acid is the degree of ionization of acid is very, very important model. Option A is equal to 5 10 to the power of minus 2, 5 10 to the power of minus 3. Option B is equal to 2 into 10 to the power of minus 3. Option C is equal to 5 into 10 to the power of minus 2. And option D is equal to 2 into 10 to the power of minus 2. So very close options. First of all, we'll see how to calculate this numerical. They are given pH value of the monobasic acid. Monobasic acid means here its basicity is 1. Its basicity is 1. Since basicity is 1, they are given monobasic acid. Now we need to calculate concentration of degree of ionization of acid. So they are asking degree of ionization of acid. First we'll find degree of ionization of acid. So the formula for this is very short formula I'm giving. You can just see solution I'm writing here. Please note it down. This is important formula. So concentration of OH minus is equal to percentage, that is degree of dissociation, that is alpha by C, implies percentage is equal to concentration of OH minus into C. So what is the concentration of OH minus is given from pH values. Since pH is equal to 5, implies pOH is equal to, since it is basic, so monobasic acid. So pH is equal to 5, then concentration of H plus ions is equal to minus 5. I'll just make it clear. Concentration of H plus is equal to percentage by C. By this you can say percentage is equal to concentration of H plus into C. Concentration of H plus into C. So because alpha is equal to H plus into C concentration, since pH is equal to 5 implies H plus concentration is equal to 10 to the power of minus 5. So it becomes, therefore, concentration of, percentage is equal to, therefore, percentage is equal to, percentage is equal to 10 to the power of minus 5 into 0.005. That is 5 into 10 to the power of minus 3. We can write 5 into 10 to the power of minus 3 because 0.005 can be taken as 5 into 10 to the power of minus 3. I'm writing here, please understand. So 10 to the power of minus 3, 10 to the power of minus 2. So it becomes 5 into 10 to the power of minus 5 and minus 3. It becomes 5 into 10 to the power of minus 2. By 100 into C. By 100 into C. So by 100. Just I write the clearly again. So by this you can write percentage is equal to 100 into C into H plus concentration. So into 100. Into 100 also we have to take. So 5 into, so percentage is equal to, what is the formula for finding percentage? H plus concentration into C into 100. H plus concentration into C into 100. So please note down. Formula I have written wrong. H plus concentration is 10 to the power of minus 5 into C value is equal to, C value is 5 into 10 to the power of minus 3 into 100. 100 means 10 square. So 10 to the power of minus 1, 10 to the power of minus 1, 10 to the power of minus 5. So 5 into 10 to the power of minus 4. So this should be 5 into 10 to the power of minus 4. This should be what? 5 into 10 to the power of minus 4. So in this way, you'll get third option. So it is equal to 5 into 10 to the power of minus 4. So this is the question. A monobasic acid solution has pH value. Its molarity is also given. pH value is also given. From pH, we can find H plus concentration. And this concentration is different than H plus concentration. So percentage is equal to percentage by 100 into C is equal to H plus concentration. And percentage is equal to H plus concentration into C into 100. Suppose if it is a base, OH minus concentration into C into 100. And so pH is equal to 5 is given. So H plus concentration is equal to 10 to the power of minus 5. So percentage is equal to 10 to the power of minus 5 into 5 into 10 to the power of minus 3 into 10 to the power of 2. So this becomes 10 to the power of minus 1. So 5 into 10 to the power of minus 1 into 5 into 10 to the power of minus 6. So this should be 5 into 10 to the power of minus 6 is the answer exactly. Because plus 2 minus 3 becomes minus 1 minus 5 becomes minus 6. Maybe they have given option wrong. But in this way, you have to calculate. This formula is very, very important. Please note it down. So this is model number 7. Please note it down. Very, very important, this model. Next question. Next model number 8. So in pH, we have so many models. Model number 8. A weak monobasic acid, monoacidic base. A weak monoacidic base. A weak monoacidic base has pH value of 5. Base is 5% ionized. They are given percentage also. Is 5% ionized. In 0.01 molarity solution. In 0.01 molarity solution. The hydroxide ion concentration in the solution. They are asking us to find the hydroxide ion concentration. Means first we have to find pH, then we have to find pOH. So the hydroxide ion concentration is option A, 5 into 10 to the power of minus 2. Option B, 5 10 to the power minus 4. Option C, 5 10 to the power minus 10. And option D is equal to 2 in 10 to the power minus 11. So these are the 4 different options they are given. So what is the formula? Since already we know the new formula, that is concentration of OH minus is equal to. So this type of model is also very important. So concentration of OH minus is equal to, because they are asking hydroxyl ion, hydroxide ion concentration. So hydroxide ion or hydroxyl ion is both same. So concentration of OH minus ion is equal to percentage by 100 into C, straight formula. So percentage is given 5% by 100 into concentration is given how much? 0.01 means in 10 to the power of minus 2 into 10 to the power of minus 2. So by this we can write 10 to the power of 2 becomes 10 to the power of minus 4. So this becomes 5 into 10 to the power of minus 4. 5 into 10 to the power of minus 4. Option is second option. So this formula is very, very important. This is a shortcut formula which I have given for you. And how this formula proof also I'll give you whenever we get time in the lectures. So right now these models are important. So that's why I have given. So this is very, very important model. Please note it down. Next question. Next question. Model number 9. Because pH only so many formulas are there. So that's why I'm giving you model number 9. 2 grams of sodium hydroxide per 250 ml of solution, per 250 ml of solution is added to a buffer solution. What is buffer solution? We'll discuss later on. To a buffer solution of buffer capacity 0.2 of buffer capacity. So this is based on buffer solutions. It's better to discuss this problem after clearing this buffer solution. So I'm not discussing this model. So model number 9, please note it down. It's very, very important model. Please note it down. The pH of a solution. The pH of a solution at 25 degrees C, that is standard temperature, is 2. If its pH is to be changed to 4, is to be changed to 4, the concentration of H plus ions should be the concentration of H plus ions should be option A, doubled, option B, halved, option C, increased by 100 times, increased by 100 times, and option D, decreased by 100 times. This is very, very important question and more conceptual based question. Please note it down. It's simple in this case. So for this, I'll write the solution here. Please see here carefully. Since in the first case it is pH is equal to 2. So implies H plus concentration is equal to 10 to the power of minus 2. And second case, to make it pH is equal to 4. Implies H plus concentration should be equal to 10 to the power of minus 4. So to bring from 10 to the power of minus 2 to 10 to the power of minus 4, we should decrease it by 100 times. If we decrease it by 100 times, then if we take 10 to the power of minus 2 by 100, it becomes 10 to the power of minus 4. So answer is decreased by 100 times, decreased by 100 times. So if you dilute it by 100 times more, so then the pH value becomes automatically equal to 4 from 2. In this way, you'll get the question. Please note it down. Very, very important model. So with this, I'm stopping this lecture, and more about pH problems we'll do, and more about pH topic also we'll do in the next session. So I hope you will understand it better way, because all the problems we are giving you in a simple and defined manner. So please follow what we discussed. Thank you all.